In order to use function notation, we first have to have a relation that is a function. Once we've figured out that a relation is a function, to write it using function notation, we need to determine the rule for that relation. Once we've figured out that we have a relation that is a function, we've figured out the rule for that relation. When we write it in function notation, we make that relation continuous. If we look at this relation here, my input value is x and my output value is y. For every x, when I do this math, I only get 1 and only 1 y. So this relation is a function. To write it using function notation, I'm going to make one slight change. I'm going to keep my equal sign and my negative 3x and my plus 5, but I'm going to replace y with the notation f parenthesis x. F parenthesis x is function notation. It's pronounced f of x. The f is the name of my function. F is commonly used to name a function, but I can really use any letter I want, G or H or J. And x is my input value. So this is really saying I have the function f of whatever input value I put in for x. So if I want to determine f of 1, I'm going to take my function f and I'm going to input 1 for x. So anytime that I see x in my rule, I'm going to replace x with 1. Now when I replace x with 1, I want to make sure that I put 1 in parentheses in order to preserve the order of operations. Now I just do my math. Negative 3 times 1 is negative 3. Negative 3 plus 5 is positive 2. So f of 1 is 2. If I take the function f and I input 1 for x, my answer will be, after I do all the math, 2. Looking at the graph, if I input 1, if I go 1 in the x direction, my output is 2. Now normally we'd call that the ordered pair 1, 2, but in function notation it's f of 1 because I'm going to input 1 and when I output I'm right here. If I want to input 5 into my function, I'm going to use the function notation f of 5. Now this doesn't mean f times 5, it's the function f of the input value 5. So I'm going to replace x with 5 and then do my math. Negative 3 times 5 is negative 15. Negative 15 plus 5 is negative 10. So f of 5 is negative 10. If I input 5, my output is negative 10. If I go 5 in the input direction, my output is going to be 10. So this point is the function f where I input 5. If I want to input 1 into my function, f of negative 1 is going to be negative 3 times negative 1 plus 5. Now I just do my math. Negative 3 times negative 1 is 3. So f of negative 1, when I input negative 1, my output is 8. If I input -1, my output is 8. So this point is the function f evaluated at -1. If you notice, all of these points are collinear. I've determined the rule, and I found that these points are collinear, so I'm going to make it continuous. To make it continuous, I'm going to connect my points. You've studied functions before. When you've studied lines, you're really studying functions. If we look at this line, the slope of this line is -3. 1, 2, 3, and over 1. 1, 2, 3, and over 1. With a y-intercept of 5. Now that I've made my function continuous, I can use this continuous function to predict other values for the function. If I want to determine f of 2, I can use my graph. If I input 2, my output is going to be right here. If I input 2, my output is going to be -1. Now I can see that on my graph, input 2, output -1, or if I plug 2 in for x and I do the math, I do get -1 for an answer. So the graph and the function notation should go hand in hand.